So we've looked at our primary controls, the primary effects and secondary effects of those controls. We now have a couple of ancillary controls that we need to look at. So the first one we're going to look at is flap. Now to lower the flap, on the right hand side of the instrument panel, down underneath the instructor's control column, is the flap lever. The flap lever has three positions. We have flap 10, flap 20 and full flap, which is 30 degrees. Now you operate that flap lever by pushing it down to the first detent, then out and down to the second detent, and then out and down to the third detent. Lowering the flap will change the camber of the wing, and it also increases the wing area of the aerofoil. And if we look back to our pilot's lift formula, an increase in angle of attack by changing the camber of the wing will generate more lift, and it also generates more drag. So if we don't allow for that increase in the extra lift, the aircraft is going to balloon. Now if we have a look at the animation to the bottom of the screen, we can observe the flap extension without any allowance for the balloon effect. And as you can see, as we cruising from right to left and we extend the first stage of flap, the aircraft now starts to balloon, which will have a gain in altitude. Once the aircraft then starts to slow down, the balloon will then level out back to its normal position. So if we were to compensate for the effect of the balloon, what we have to now do is couple the controls. So as we extend our first stage of flap, in order to stop the aircraft from ballooning or gaining altitude, we have to push forwards on the control column. And we'll keep pushing forwards until we maintain our constant altitude. Considerations and the use of trim. Before autopilot was invented, pilots had to trim their aircraft for long stages of flight. If we didn't have trim, you would be holding in that back pressure or forward pressure for a long period of time. Trim was invented and it's used to relieve the pilot's elevator control load in flight. To relieve the pilot's constant back pressure of the control column in a climb, we're going to rotate the trim wheel in a downward direction. So if you're pulling on back pressure or applying back pressure, you trim down until the back pressure input is no longer required. Likewise, if we relieve the constant forward pressure on the controls in a descent by rotating the control wheel in a forwards fashion. Now you can see on our elevator we have the horizontal stabilizer, which is a large aerofoil section. We have the elevator at the back, and then the tiny tab at the back of the elevator is the trim tab. Now, as you can see, the further from the horizontal stabilizer to the back, the smaller the controls get. As we increase a distance from the datum, the effect of that, if it was a larger elevator, would be a lot greater. So we have a very small trim tab because the impact that it has on flight is quite great. So when you are trimming, you need to trim very concisely, smoothly and coordinated. And you can see that we're changing the chord line to generate more lift further out from the horizontal stabilizer, which allows us to maintain level flight quite easily. Now if we were to combine the example of the balloon with flap, we extended our first stage of flap, the aircraft ballooned, and we're now pushing forwards on the control column, it can get quite heavy. So if you're just sitting there pushing forwards on the control column for a long period of time, your arms are going to get tired. So what you can do is, if we're applying forward pressure, you can trim forwards to then fly in level flight with your flap extended. Considerations: mixture. Mixture is used to adjust the air-fuel ratio in the engine. The air-fuel ratio is what we call a chemically correct mixture, and it's approximately 15 parts of air to 1 part of fuel. The mixture control lever is located to the left of the flap and to the right of the throttle, and it's red. Now when we're starting the engine or when we're flying, we can use the mixture control to control how much fuel is going into the engine. The way we control that is by pushing the little button in and then pushing the mixture full rich, which means we're putting more fuel into the engine. If we then push our button in and pull the mixture out, what we're now doing is moving the mixture control into the idle cutoff position, which will take all of the fuel out of the engine. We also have the throttle. Now the throttle adjusts the power delivery from the engine. If we push the throttle all the way in, or full power, full throttle, the aircraft is going to increase the RPM, or the revolutions per minute, and it's going to accelerate quite quickly. If we then pull that throttle out to idle, there's no power to the engine, which means the aircraft is now going to slow down quite quickly. It's important that when you are operating the throttle, that you have smooth control inputs We don't just push it all the way in and pull it all the way out. We smoothly push the throttle in and we smoothly pull the power out. The slipstream effect. The slipstream effect will either increase or decrease with a change in power. If we increase the power, the slipstream effect is going to increase. And if we decrease the power, the slipstream effect is also going to decrease. Now, the propeller is rotated clockwise when viewed from the cockpit, creating a backward spiral airflow. As you can see on the picture, the airflow is now moving, it's being pushed back around the fuselage and it's spiraling around it, and it hits the horizontal stabilizer or the rudder on the left-hand side. As a result of that, it will cause the aircraft to yaw to the left. And a good way to overcome that as a pilot is to increase the right rudder as you increase power. This is very important. You'll be flying this aircraft for a long period of time, in fact 2 years, and you need to understand how the slipstream effect works. So as you increase in power, you'll also need to increase right rudder. How much? Enough to keep it balanced or enough to keep it centered on the runway centerline. Now, an increase in power also causes the aircraft to yaw to the left, and will also cause it to pitch up. So what you're going to have to do again, when you increase power, the slipstream effect also increases. You're going to have to increase the right rudder if you're on the runway. If you're in flight, you're also going to have to push forwards on the control column, and you're also going to have to increase your right rudder. Now, if you were just to leave those controls set where they were without changing them, they can become quite heavy. So we'd have to use a little bit of forward trim to then trim out the control forces. Now, the opposite occurs with a decrease in power. If we pull that power out, the aircraft's nose will then pitch down and it will also yaw to the right. So in order to maintain level flight or control of the aircraft, we have to apply a little bit of back pressure and a little bit of left rudder. High airspeed. So as we increase our airspeed, the controls are going to feel heavier and firmer. So as we increase our airspeed, we're going to get a greater control response from any given control surface deflection. So if we're traveling quite fast and we put in a great control input, the effect is going to be quite large. Like when you're driving a car and you're going very fast, or riding a bike, the faster you go, the smoother and the smaller control inputs you make, as you'll get a very large result on the outside. So we've just looked at high airspeed, and we're now going to look at low airspeed. So at a low airspeed, our controls feel light, but they are less effective. So if we're comparing a turn at a high speed, the control input we put in was very little. At a low airspeed, we're going to have to put in a lot of control input to get the same result. So at a lower airspeed, the controls are less responsive, so greater control inputs are required. It's like when you're driving a car very slowly in the car park, you have to move the steering wheel a lot to get the car to do what you want it to do.